Hello, welcome. So we're going to talk about linear second order differential equations, I should say. Okay, so now linear second order differential equations are of this form. So of the form uh, a y double prime plus by prime plus cy equals, and we're going to take this as a function of t, f of t. Okay, now if f of t equals 0, this is called homogeneous. Same word as what we were using before for something different, but it has a different meaning. In fact, even in the book they point that out. This has nothing to do with the other homogeneous. I always think that when you use a word in the same way, or the same word in mathematics, that there's a connection somehow, but I don't know the connection between these two. Okay, so homogeneous. So let's go ahead, and what we do is how we solve the homogeneous one is we make an assumption. We assume that y is e to the rt. Okay, so if y is e to the rt, that means y prime is re to the rt, and y double prime is r squared e to the rt. Okay, so our differential equation actually ends up becoming an algebraic equation. R squared, there's an e to the rt, but we're going to cancel that out, plus br e to the rt plus c e to the rt equals 0. So we get ar squared plus br plus c equals 0. Okay, now that's a quadratic equation, isn't it? And we know how to solve that. R equals negative b over 2a plus or minus square root of b squared minus 4ac over 2a. Okay, so that's just a basic first sort of thing that we need to learn. Okay, all right, let's go ahead and do just like a very simple one. Let's take, let me see if I have one written down. I do. Let's take y double prime minus 5y prime plus 6y equals 0. Okay, so if we do that, we're going to make our substitution. Y equals e to the rt. Okay, and so we're going to get r squared minus 5r plus 6 equals 0. That factors into r minus 3, r minus 2 equals 0. So r equals 3 or r equals 2. Okay, so you get our solution. Okay, we're going to write it as a e to the 3t plus b e to the 2t is equal to y of t. And a and b are going to be determined by initial conditions. Okay, so you have two unknowns, so you need two initial conditions, which makes sense because your differential equation is second order. So if your differential equation is second order, you're going to need two initial conditions. Now, let's go ahead. I'm not going to solve it as a matrix system, but I want to show you what we did as the matrix system, okay? And after we do that, later on, we'll come to how to solve it. But how can we write this as a matrix system? Sort of like what we were talking about in the other videos from yesterday. Okay, so you've got y double prime minus 5y prime plus 6y equals 0. So I'm going to let y1 equal y2 equal y prime. Okay, so then y1 prime equals y2. y2 prime equals, remember y2 prime is the double prime of y. So that's going to equal what? 5y prime minus 6y, which is 5y2, sorry, 5y2 minus 6y1. Okay, so if we want to write this as a matrix system, then we're going to get y1 prime, y2 prime equals 0, 1, negative 6, 5, y1, y2. And we're going to learn how to analyze that later, okay? But I just wanted you to see how you could write this as a matrix system, okay? All right, I'll see you in the next video.